Hello everyone, in this new video we are going to test the computer vision capability of the Nvidia Jetson TX2. In particular we will test the VisionWorks library made by Nvidia. First of all, let's start the terminal and let's use the new amazing script made by Nvidia, and you can see there is a Jetson clock.sh script, and if we run the script with the sudo Jetson clock using the show option, we can see the clock speed of the cores of the Nvidia Jetson TX2, the frequency of the GPU and of the memory. And as you can see, the last voice is the fan speed, and is 0 because the fan speed is not running. And this is the minimal configuration to run at minimal capabilities and a lot of less power consumption. And if we run the same script without the show option, like this, you can see the fan is running, and we can compare the frequency of the cores. Now we have more than doubled the frequency of the GPU number 1 and number 0 the number 1, sorry, and number 3, number 4, number 5, that are the core of the A57 processor, and the frequency of the CPU1 and CPU2 are more than doubled again, and they are the core of the Denver processor. As you can see, also the current frequency of the memory of the GPU has been enhanced, and the same for the frequency of the EMC, that is the memory. You can see also that the fan speed has been moved from 0 to 255. So with this configuration we are ready to test computer vision algorithms at full power, at full computational power. So let's install the VisionWorks example that are ready to be installed with the default configuration of the Jetson TX2, and they are located in /user /share /VisionWorks. Okay, and there is a script named sources, and there is a script named install samples, and we must tell the script where to install the example. We install them in the devel folder. Devel folder is a folder that I use for my development code for everything I'm creating. And so let's do it. Okay, we can go to devel, and we can see a new folder named VisionWorks 1.6 samples. We enter the new folder, and we can run the make with the option J6. We have 6 cores, so we can make EV parallel compilation of the example. So let's start. Now the compilation is running. It can take a bit of time to compile, and we are waiting. I tested the example before, and they are really interesting because Nvidia creates a good set of examples demonstrating the real capability of the GPU of the TX2 with useful computer vision algorithm. So we are ready. We have a bin folder. We are going to the bin folder, ls. Okay, let's make a bit of space, ls. We have 3, 6, 10 example to test. So let's start from the first. It's a simple feature tracker, so we can run it with mvx demo feature tracker. Okay, this is a simple feature tracker algorithm that as we can see in the info rectangle, we have an iris detector on a video running at 1280 at for 720 pixels, and it's running the display is running at 30 fps, but the algorithm is running at more than 1000 fps. What does this mean? This means that we can have a real feature tracking for real-time application in 720p video, and this is really important for visual odometry, for obstacle detection and other algorithms to be used for automotive, for robotics. Okay, this is the first video. Let's try the second demo. Ls, and we can see the same algorithm applied to MVXCU and it's exactly the same, but using other library made by VisionWorks with the CUDA calculation, I think. So let's go to the next. Really important because it's a demo that demonstrates the use of the half transformation. Half transformation is really important in computer vision because we can use it to detect line and to detect circles in a scene. In this case, we can see the line detected by the half transformation, and we can go back here. If you see the wheel of the truck, it's detected here and here, and it's running at more than 300 fps again, so really useful for real-time application. Okay, let's go to the next example, and the next example is motion estimation. Motion estimation is really important for video surveillance because we can use it to detect what's changing in the scene. In this case, people are walking, and we can track everything is changing. So the people, we can detect not only who is moving, where mouse, but also where is moving. Okay, and it's running at more than 100 fps, the algorithm. Again, real-time elaboration. Okay, really important, really amazing. So the next, stereo vision. Okay, MVX, sorry, demo, stereo matching. And this is an algorithm applied to a stereo camera running at VGA resolution, and we have 3D detection at more than 60 FPS, really often more than 70 FPS. And we can see this is the video running at elaboration speed, and this is the depth map. Not really easy to look at it, but in RGB color we can appreciate the depth. Each color is a depth of the object in the scene. We can see the trees and the cars. We can appreciate the 3D estimation. We can make a pause, and this is a road scene. This is the road, trees, a car here running at more than 70 FPS. It's really important for automotive to see obstacle, to see what's in the really near to the car, to detect obstacle and to react to them. Okay, let's go to the next. Video stabilizer. Okay, MVX, demo, video stabilizer. Okay, this is a video acquired by a moving camera. On the left there is the raw video without elaboration, the original video. You can see that there are a lot of vibration in on the right. We have stabilization of the video at more than 300 FPS, so we can really correct the movement made by the human that's manually acquiring the scene, and we can appreciate the video and without problem. Okay, let's go to the next. LS. Okay, we have now 4 sample, not demo. They are exactly the same. Sample object tracker. Object tracker is really important to not only to detect something moving in the scene, but also to keep our attention to one thing that is moving. In this case, a car. There is a rectangle on the car, and we can track it. With the mouse we can select the object to be tracked, and the video continue, and we can see how the algorithm continue to track another object. So we have multi-tracking, another here, another here. We can select to track the bridge and one of the light here, and then continuous tracking. This kind of object tracking is made using a feature. So we can select the object here, and we can see the feature now. Okay, the feature extracted by the algorithm. There are this point, colored point here, and this rectangle here in chain. In chain is the rectangle of the feature, and we can see how the algorithm adapt itself to the feature moving and continue to track them frame by frame. We can also select a rectangle with more than one object to be tracked, and we can see how it adapts to the changes in the scene. I'm using this same algorithm for real-time application to track boat on the sea. With a moving camera, I can select a boat, a navy, and the moving camera continues to keep the moving boat in the center of the scene. The algorithm is the same. It's running not on a TX2 Jetson board, but on a TK1 board. It runs at about 15 FPS, and here we can see that it can run more and more faster than 15 FPS. So it's more and more than 30 FPS, I think. But 30 FPS is the visualization FPS. The algorithm is faster and faster. So the step between the first Jetson board, the TX1, and the latest TX2 in 3 years is really amazing. A really good job made by Nvidia. So let's go to see the latest sample. What's here is really important with the VisionWorks library made by Nvidia is the interoperability with the OpenCV. We can see it working with the sample OpenCV MPP. Okay, these are algorithm available in OpenCV. Is a simple merge algorithm, but what's important is that we are rendering the result with MVX with the VisionWorks, and the algorithm are taken by OpenCV, and we can see more than 3000 FPS on 512 for 512 pixel resolution image. Okay, but VisionWorks can be used also with OpenCV. With OpenGL. Okay, MVX sample, and in this case OpenGL is used to render a video, the same video as before for the car tracking. In this case it's only simple rendering, but this to demonstrate how we can use OpenGL to render the scene, so we can integrate VisionWorks with the Simple Guy application. And here in the processing we can see that the display time is about 20 milliseconds. Okay, the last is another simple player, MVX sample player. Okay, again the same video with the displayed using the VisionWorks tool to display video, to display frame, and so elaboration. And what's really important is that all these demos, all these examples are open source, and we can find the code here in the devel VisionWorks sample, and samples here there are the code. Okay, this is the C++ code to use it to create the, in this case, the sample, and the demos are here: video stabilizer, feature tracker, half transform, motion estimation. Everything we have seen before is available here. Okay, You can see the feature tracker, main feature at the main. Here the algorithm created with the VisionWorks SDK. Okay, the parameters here for feature tracking. We can we can adapt the algorithm to our video, to our source, and we can change the parameter of the algorithm to see how the result is changing. Everything available, everything ready to be used and to be understood. Okay, so here we have done not really short but really interesting exploration of the capability of the Nvidia TX2 for computer vision application using the VisionWorks library by Nvidia. A library that will be really useful also for robotics application. Here's my robot, and for automotive, for video surveillance, and so on. And it will be really interesting to apply to this library, to VisionWorks, also the artificial intelligence using deep neural network, everything available in with the latest jetpack. The jetpack 3 is almost ready, and we will use artificial intelligence algorithm to not also detect object, but also to understand what kind of object we have in front of our camera and to react to consequently. So see you to the next video. Thank you for your attention, and goodbye.